In example 4, we have an actual problem from real life. If you're watching this video as part of my class in high school, then you'll know, should know a little bit about this. The football team has a ramp back there in the practice fields, or at least, a shed. And the shed needed a ramp to be built. The old one was kind of not doing so well. If you don't go to school at Lakes, and that's in northern Illinois, next to Antioch, we're in the town of Lake Villa, then you wouldn't know about this, but I'm telling you, it is there and it needed a ramp. And yours truly built the thing. So the ramp needs to be 24 inches in length, and that's just 2 feet. That was the size of plywood that I had, with a rise of 4.5 inches. And that's how far the shed was off the ground. You can imagine if the shed was right on the ground, you get a bunch of water and stuff. So usually sheds or houses or what have you are raised up a little bit. We want to find the angle of elevation. When I was doing this for real, I was finding the elevation so I could set my saw blade. Because if you don't cut off a little bit, what's going to happen, this is going to be real close, like this is the plywood right here. And here's the edge of the shed. And so then the football team has all their gear and stuff up in here, and this is like a zoomed in view, is this little gap right here. So this little gap starts to collect like rocks and things of that sort. So if we could only cut this off at the right angle, then this piece would butt right up against this piece, and there wouldn't be any room for any of that stuff to get in there. So it just makes for a nicer experience overall, and then it's going to last a lot longer. Hopefully it is. So you can talk to the football team if you want, see if it is there still. So anyway, what I needed to do is set up this right triangle here. I needed to figure out this angle right here, this angle of elevation. That's the same angle as the little one right here, so I need to set my saw blade at that angle when I cut the plywood on edge. And we know that this is 24 inches right here. This is the actual ramp itself, and that's just, sheets come in usually 4x8, but for some reason I had a piece that was 2 feet. And so then the 4.5 inches was the rise here. So this was how far up we needed to go to get to the shed, and that's why the ramp was needed. If we want to look at this angle theta here, we've got opposite and hypotenuse, so we can set this up as the sine of theta is equal to opposite over hypotenuse. Remember, we need to do the inverse sine, so we'll do the inverse of 4.5 over 24, and that should give us our angle measure. We're going to do this in degrees. When I'm doing woodworking like this, I don't do it in radians. That's kind of silly. Most everything is done in degrees for those types of applications. So we'll do 4.5 divided by 24, and that gives us about 10.8. Now for me, I was not good enough to set my saw blade to the nearest tenth, but I did try to set it to the nearest degree, although I'm not sure how close I really got, but it seemed to fit pretty well when I put it on the ramp. So that just gave me the tilt that my saw blade needed to have when I ran the piece of plywood through there. There you go, a practical real-life application. If you use trigonometry, you can figure it out.